All right, let's dive right in. Today, we're talking about the absolute core of how code actually works. We're talking about operators. These are the action words, the verbs, the fundamental building blocks that make a program come alive.
I mean, have you ever stopped to think about that? We write all these lines of code, but how does a computer know to add something, or compare two things, or save a piece of information? How does it go from being just text on a screen to a real action? Well, that's the big question we're tackling.
And the answer, believe it or not, is pretty straightforward. It all comes down to operators. These are the symbols, like the plus sign, the minus sign, the equal sign, that are literally the verbs of the programming world. They're the commands that tell the computer what to do. Without them, our code would just be a list of things with no action.
So, let's get to know these action words a little bit better, shall we?
Okay, so here's the basic lingo. Every time we use an operator, there are really two main parts. You've got the operator itself. That's the symbol, like the plus sign. And then you have the operands. Those are the values or variables that the operator works on. So in 5 plus 3, plus is the operator, and 5 and 3 are the operands. Easy enough, right?
All right, now that we've got the vocabulary down, let's start building our everyday toolkit. And we're going to kick things off with the operators you probably recognize from way back in math class. First up, the classics, your arithmetic operators. These do exactly what they look like they do. Add, subtract, multiply, divide. The one here that might be new to you is modulus, that little percent sign. It's actually super cool. It just gives you the remainder of a division. It's the secret sauce for doing things like, say, checking if a number is even or odd.
Now here's a fun little quirk. The plus operator kinda has a split personality. When you use it with numbers, yeah, it adds them. But when you use it with text, or as programmers call them, strings, it actually joins them together end to end. It's a great example of how a single operator can pull double duty depending on the situation. Next, let's talk about assignment operators. Their whole job is to put a value into a variable. Think of it like putting something into a labeled box to use later. The single equal sign is the one you'll see the most. But there are also these really nifty shortcuts like plus equals or minus equals that do a little math and then save the result all in one step.
Okay, this is a big one. Seriously, this trips up almost everyone when they start programming. It's the difference between one equal sign and two. A single equal sign is a command. It's you telling the computer, hey, make this variable equal to this value. But a double equal sign, that's a question. That's you asking the computer, hey, is this thing already equal to that thing? One is an order, the other is a question. Getting this right is absolutely crucial.
All right, we've got the basics down. Now, who doesn't love a good shortcut? Let's look at how we can make our code a bit cleaner and more efficient. These are called unary operators, and that fancy name just means they only need one operand to work their magic. The most famous ones are increment and decrement, which just add or subtract 1. And then there's the logical not operator, that exclamation point, which just flips a true value to false or a false value to true. Let's focus on that increment operator, plus plus, for a second. You are going to see this thing everywhere, especially when you're counting stuff, like looping through a list of items. Instead of writing out x equals x plus 1, you just type x plus plus. It's short, it's sweet, and it's basically a universal sign of a programmer at work. Now we get to the really cool part. This is where we give our programs a brain. This is how we let our code ask questions and then make decisions based on the answers it gets. And we do that with comparison operators. This is the toolkit our program uses to compare two values. Is this number bigger than that number? Does the password match? And the answer to any question you ask with these operators is always a simple true or false.
And you really can't overstate how important this is. Every complex decision a piece of software makes, from deciding if you can log in to landing a rocket on another planet, it all boils down to a huge number of tiny, simple yes or no questions. This right here is the absolute foundation of logic in code.
But what if one question isn't enough? What if you need to check a couple of things at the same time? Well, that's where logical operators come into play. The ampersand, or the and operator checks if two conditions are both true. And the VV, the two vertical bars, that's the or operator, and it checks if at least one of the conditions is true. So, take a look at this example. For this whole statement to be true, x absolutely must be greater than 4, and y absolutely must be less than 8. If even one of those is false, the whole thing is false. This is how you start to build really complex rules and intelligence into your programs.
Okay, so we've got all these different types of operators. But what happens when you mix them all up in a single line of code? Who gets to go first? That brings us to our final section, the rules of the game.
And they should feel pretty familiar. Remember learning PEMDAS or BODMAS in school for solving math equations? Well, programming languages have the exact same idea. It's called order of precedence, and it's a strict set of rules that make sure code runs predictably every single time.
So here's a simplified look at that hierarchy. Right at the very top, just like in math, are parentheses. Anything in parentheses gets done first, period. Then come those unary shortcuts we talked about, then multiplication and division, then addition and subtraction, and so on, all the way down the list. The assignment operator, it almost always goes dead last.
So when we combine all of these pieces, our variables, our values, our operators, and we follow those rules of precedence, we create what's called an expression. You can think of it like a complete sentence that the computer can read, evaluate, and boil down to a single final answer.
And here it is, a perfect example of putting it all together in one powerful line. This uses a special little shortcut called a conditional or ternary operator. Here's how it reads. First, the computer asks the question in the parentheses, is y greater than z? If the answer is true, it uses the value after the question mark, which is y. If the answer is false, it uses the value after the colon, which is z. And finally, whatever value gets chosen is assigned to x. It's a super compact way to make a decision.
So, there you have it. Arithmetic, assignment, comparison, and logic. These operators are the true building blocks that let us turn simple data into smart, complex applications. You now have the fundamental toolkit for creating logic. So the only real question left is, what are you going to build with it?